Welcome back to the deep dive. Today we are heading up high, way up into the surprisingly high-stakes world of aerial construction.
We are. And our mission today is a deep dive into installing messenger wire. That's the weight-bearing strand that really it holds up the entire digital nervous system of the modern world.
And if you think this is just some, niche technical topic, you have to think about the environment this stuff has to survive in.
Exactly. We're pulling our knowledge from this just definitive, no BS guide. It was put together by a veteran with 21 years in the field.
And he's specifically talking about the brutal realities of, say, Canadian winters.
Oh, yeah. Gale force prairie winds, relentless ice loading. It's a tough environment.
And the stakes, they couldn't be clearer. Our source frames the immediate problem so perfectly.
He does.
He asks, how does a basic failure in aerial construction, something as simple as cable sag, turn a $100,000 network build into what he calls a low-hanging piñata for transport trucks?
It's such a great visual. And it's an insurance claim just waiting to happen. It's that catastrophic failure that always, and I mean always, happens at 3 a.m. in the worst possible weather.
So our mission for you, the learner, is to really extract the essential hardware and, maybe more importantly, the processes that guarantee this stuff lasts.
Right. We're focusing on separating a professional, durable installation from, a costly shortcut. This isn't just about meeting the minimum standard.
No.
It's about meeting the standard that prevents that cable from failing 10 years from now. You need to know the difference between durability and disaster.
Okay, let's unpack that. Let's start with the foundational components, the physical armor we put up there.
Right.
The veteran is absolutely adamant about avoiding what he just calls the cheapest Amazon junk.
And he's right to be. He insists on using workhorses that survive ice loading, gale force winds, and 20 years of UV punishment.
So what's the must-have hardware? What ensures that kind of integrity?
Well, the structural starting point is termination. It's all about how you anchor that high-tension wire.
Okay.
And for that, the gold standard is the big grip dead end. You'll also hear them called preformed grips.
Preformed grips, got it. But there's a real micro detail here that our source points out, something that separates the pro from the amateur. It's about alignment.
Yes, this is so critical. When you're applying those preformed grips, you must use the crossover mark that's imprinted on it as your witness mark for alignment.
Why is that one little mark so crucial?
Because it ensures an even distribution of friction and tension. If you start wrapping that grip even slightly misaligned, the whole load isn't distributed evenly across the spiral.
And that creates a weak point?
A huge weak point. It's where the grip can start to slip over time, which means you lose tension, and that leads directly to sag. That little mark ensures the friction is uniform across the entire termination.
That makes perfect sense. Okay, so moving along the span, we need supports. What keeps the cable attached to the poles on a straight run?
That's where you use tangent suspension clamps or drop clamps.
Bolt clamps.
Yeah, you use them on straight sections or for really small angle changes, like less than 15 degrees. But what's fascinating here is the material choice.
Right.
The pros insist on aluminum clamps with rubber inserts.
Now, hang on. Given the huge tension and the weight we're talking about, especially with ice, why not heavy-duty steel clamps? Wouldn't that be stronger?
That's a great question, but here, strength is actually secondary to material compatibility. If you use those cheap, hard steel alternatives.
It's too aggressive.
Way too aggressive. As the source says, they will chew messenger like Deaver. They cause abrasion, fatigue, and they strip off the protective galvanization on the strand.
Ah.
So the aluminum with the rubber, it offers a firm grip, but it doesn't create those microscopic friction points that lead to failure during high wind vibration.
So be strong, but be kind to the core material. I get it. Okay, next up, lashing wire clamps, also called D-lash or snowshoes.
Their job is pretty simple. They terminate the thinner lashing wire that binds the actual fiber cable to the messenger.
And the rule here is absolute.
It's non-negotiable, especially in ice loading zones. You need one clamp per side of the pole on every single pole, no exceptions.
And skipping that is just asking for trouble.
It's a classic amateur move. It just invites the cable to separate from the messenger in a storm.
All right, and finally the safety component that protects everything downstream. Bonding and grounding clamps.
These are, again, non-negotiable for safety and for system integrity. We're talking about parallel groove clamps for number 6, copper bonding wire.
And this is all about lightning, right?
It's about giving transient voltage. So yeah, lighting a path to ground. You have to bond every 4 to 6 poles minimum or whatever your local code says.
The veteran's quote on this really sticks with me.
It's a good one.
He says lightning doesn't care about your schedule.
And that's the truth. It reminds you that nature is always going to enforce its own deadline.
Which brings us directly to our second segment, the science of precision tensioning. This is that critical pre-planning size that, if you skip it.
You're guaranteeing yourself a lifetime of regret and vibration failure.
So what's step one?
It's administrative, but it's essential. Securing pole permits and completing the make-ready.
Well,
You have to follow the utility-specific guidelines.
and that's not just bureaucracy.
No, not at all.
Yeah.
Those standards, they define the minimum tensile strength you need to survive a calculated ice loading event. It's physics, not paperwork.
So once the permits are done, we get into the actual physics, the science of sag and tension. You said temperature plays a massive role. Why?
It's all about the thermal expansion of steel. If you install a cable in the hot summer, that strand is physically longer. It's elongated.
And in the winter, it shrinks.
It contracts significantly. Between a hot summer day and a frigid Canadian winter, a steel strand can change in length by as much as a foot per 1,000 feet of span.
Wow, a foot.
Yeah. That's why using the manufacturer's sag charts is mandatory. They literally plot the required tension against temperature.
So if I'm installing in, say, 30 degrees Celsius heat, I have to intentionally add more slack than feels right because I know it's going to shrink later.
That's exactly it. The goal is to aim for about 1 to 2% sag during a summer install.
And that's your buffer.
That's your insurance policy against the elements. If you tension it too tightly in July, it will absolutely snap in January under the combined stress of the cold and the ice.
Speaking of snaps and stress, let's talk vibration. The cardinal rule seems to be keeping the messenger wire on the same side of every single pole.
That is the key to minimizing dynamic fatigue. Zigzagging the wire, crossing it from one side of the pole to the other.
It's a huge mistake.
It's strongly advised against. If you do that, you create uneven load points, and you get what the source calls wind vibration hell.
And that vibration just eats away at the metal.
It quickly causes metal fatigue and eventually failure. Keeping it consistent creates a uniform stress profile across the whole span.
Okay, we've done the math, we've picked our side of the pole, now we string it. You have to use proper cable blocks at every pole. What about the pole itself?
You pull with a swivel and a grip. And critically, you never ever bull wheel directly on the messenger strand itself. You're pulling through the blocks.
Right.
But the single most important rule of the entire operation is about measurement. You must use a dynamometer or a load cell.
Don't trust your feels right meter.
Never. The tension required is far too critical to be subjective. You're dealing with thousands of pounds of force.
And the process.
You tension from one end only. The other end has to be completely dead-ended before you start pulling. Anchor one side, pull from the other, and watch the dynamometer.
Let's move into our third segment then. Suspension, lashing, final integration. We've got the right tension. Now we have to lock it all down and get that clean, professional factory install look.
Right. So we circle back to the dead ends. When you're wrapping those preformed grips, the legs have to face downrange.
Downrange, away from the pole, aligned with the wind. Why does that direction matter?
It ensures the termination holds firmest under the dynamic load. Wind is always trying to pull the messenger out. Orienting the legs downrange leverages the grip's design against those pulling forces.
And along the run, what's proper suspension?
Tangent supports at every pole. But, and this is important, if you have a really long span, say over 300 feet, you need to install mid-span supports too.
To distribute the weight.
And reduce that damaging wind vibration.
Next up is lashing. This is the final step that binds the delicate cable to the strong messenger wire.
Correct. And you need the right tools for this. A spinning jenny for the wire, and a proper mechanical lasher from a good manufacturer.
And there's a professional touch here too, right? With the start and stop points?
Yes. Lashing must begin and end 3 to 5 feet past the support clamps.
Why that extra distance?
It's for stress relief. The point where the cable meets the clamp is a natural flex point. By lashing past it, you ensure the whole thing stays integrated.
So the cable and the messenger move as one single unit.
That's the goal. If you stop right at the clamp, you invite separation and movement.
Okay, everything is lashed and hung. Time for final checks. First is verifying the sag.
Exactly. You have to use a transit or a laser level to physically confirm the final sag measurement. If it's outside the range on your chart, you have to adjust it.
That's the proof.
It's the proof that you did the tensioning process correctly. And then, don't forget the administrative side.
Which is?
Double check your bonding and grounding. And tag every single pole with your company info. Some utilities will absolutely fine you for missing tags. It's the final mark of accountability.
Okay, to synthesize everything, let's run through the high-impact do's and don'ts cheat sheet. This is the condensed wisdom that, separates a durable install from a 3 a.m. repair call in February.
All right, let's start with the DOs, the precision stuff.
DO, use sag charts and a dynamometer for every single tensioning run. No exceptions.
DO, keep the messenger wire on one consistent side of all the poles to minimize that vibration damage. And DO, bond and ground properly every 4 to 6 poles, minimum.
And if you're in a place with bad weather, DO, install those snowshoes, the lashing wire clamps, in any ice-loading areas.
And remember that first detail. DO dead end with the crossover marks perfectly aligned. You need that friction distributed evenly.
Okay, now for the don'ts, the shortcuts that lead to horror stories.
First and foremost, don't ever eyeball the sag or over-tension it. If you do, as the source says, snap goes the strand when it gets cold.
And with routing, don't zigzag the messenger wire. If you do that, hello vibration fatigue, you've just halved the lifespan of your work.
And please, don't skip bonding unless you want to enjoy your lightning-fried electronics.
And this one is shocking, but it's a real-world example. Don't use a single clamp, or even worse, something like baling wire to secure high-tension loads.
It sounds insane, but people do it. Finally, don't ignore ice and wind loading calculations. That's the direct path to a January cable-on-ground party.
And that tiny detail from before, the crossover mark, don't rush those wraps. A slipped messenger during a storm just undermines everything you did.
The overarching lesson here is just so profound. The cost of doing it wrong, the failure, the downtime, the fines, it's dramatically higher than the cost of doing it right the first time.
The veteran standard is so simple and powerful. If it doesn't look like a factory install, redo it. And that's a measure of quality that should apply to any infrastructure project, really.
And for you, the learner, this whole deep dive, it highlights that durability isn't just about expensive parts. It's the meticulous process.
Yeah.
It's using a load cell instead of just your feel for it. That's what guarantees success.
Our source material ends with the veteran asking for his audience's worst aerial horror story. So we want to broaden that challenge for you. Think about the world around you. What complex piece of infrastructure in your daily life, something you rely on absolutely, do you suspect was built by someone using their feels right meter instead of a dynamometer?
Yeah, think about that one high-stakes detail that stands between something working and catastrophic long-term failure. It's something to consider the next time you see a utility line swaying maybe just a little too low in the wind.
Thank you for joining us for the deep dive. We'll see you next time.